Hello everyone, my name is Ray Konopka with Ray Software, and in today's sessions we're going to be taking a look at high DPI systems and VCL applications and what do we need to do to leverage the high DPI scaling capabilities in our applications. But before we get into the details of all of that, we need to really get a foundation of just what it means for high DPI support. What are the core concepts? What do we need to look at? What are the concerns that we have? What are the problem areas that we will run into in our VCL applications? And then once we understand what those are, we need to understand what kind of support do we get from the operating system. We are talking about VCL, so we're talking about Windows, and really we're really talking about Windows 10 because over the years Microsoft has evolved its high DPI support in a variety of ways, and it's really, to be honest, only become useful in Windows 10, as we will see as we go through the session. And we're going to take a look at the implementation details of how do we leverage some of the new capabilities that Windows gives us. But we also need to take a look at what do we need to do to handle the deficiencies that we don't quite get from Windows itself. And that's where we need to look at how do we handle our images. There's new components available that we can leverage to support high DPI in a much better way, and some even new VCL functions that will be useful in certain situations. So let's dive in. So when we talk about high DPI, there's a number of things that come to mind from various people. Specifically, DPI stands for dots per inch. You may also see it referenced quite frequently as PPI or pixels per inch. For a long time, we have been safe to assume that for all of our Windows machines, the DPI has been 96. So you've ever wondered where that came from? That's just historically the old style monitors based on the pixel size that was used. So going way back to the VGA displays and then the SVGA, XVGA, and so forth. The dots, the pixels, all stayed the same. We just got bigger and bigger sizes. We never really crammed more dots per inch into it. We really just dealt with resolution. So a lot of people seem to think that DPI is related to resolution. Well, it's similar. It's certainly related, but it is quite different. As an example, let's take a look at 4 different monitor sizes here, and going way back, old school monitor 1024, 768. You still might see these in kiosks, at train stations, airports, and so forth. Unless they're running, an iPad solution, but traditional Windows, they're still around. They're running at 96 DPI, so that means we have a physical display of 10.7 inches by 8 inches. Likewise, going to a 1440 by 900 monitor, same DPI, gives us that 15-inch wide by 9/3. So we start to see where this comes in. I have, a very large monitor, 27-inch. It's an old Apple Thunderbolt display. Love it. It's got great color, great picture. It still runs nearly 96. Its true DPI is 108.79. I'll give it a 109 DPI, but the size of it, my monitor's larger, but I'm still running at nearly, around 100 dots per inch. So my physical size is 23.5 by 13.2. We start getting into higher resolution displays in smaller form factors is really when we start talking about increased DPI. So on my laptop, which I'm running this on with the external monitor, my laptop runs at 3072 by 1920 natively. I can actually scale that up because I'm running Mac as my laptop running Windows inside of Parallels. And I do that because I do iOS development with Rad Studio as well, and so having them both on the same machines is nice. But the dots per inch on my laptop, much like the Windows Surface tablets and so forth, is much higher than 96. It's 226. And so there's the physical size of my laptop screen, but it's jam-packed with DPI. Well, dots per inch isn't the only story. The key facet to all of this is the display factor. Because if you remember, we never worried about this back in the day when we went from a 1024 to a 1440 to even this large monitor. As long as the dots per inch were the same, you just packed more pixels on the screen, you just got more space. The fonts, the icons, a 16 by 16 icon looked the same on all of those different displays. However, on my laptop, physically I'm putting more pixels there, so I can't just display a 16 by 16 pixel image because that looks so small on a 226 dots per inch screen. It's like an eighth of an inch big, if that. And so that is not recognizable. And so we need to start thinking about, well, how do we scale up our interfaces in order to present something that looks reasonably well? The other facet to the whole complicated nature of high DPI is that DPI is dynamic. What does that mean? Well, it can change because you have multiple monitors, like I actually have in this setup. I'm only showing one monitor right at the minute, but for all the demonstrations, I actually will be showing two monitors. My high definition or high resolution, high DPI, scale factor display next to my external monitor, which is not. So each monitor can have a different DPI, which is really quite powerful and cool that the OS is supported. Back in the day, they never did. It was always use the common denominator DPI that supported across all of them. But you can also have remote desktop connections. Undocking and docking your laptop to an external monitor will change the DPI that you're running at, especially if you're mirroring the display, of course. But you can also change the scale factor in the app. The user can go in and say, I want Windows to be running everything at 200% right now, or maybe I want it to be 300%. So those scale factors will come into play. And so we need to be able to be responsive to that. So let me show an example of what all this means with multi-monitor support. So here I have a split view. I've actually recorded two of my monitors. So on the left hand side, I've got my laptop monitor, which is running at 250% scaling. It's a MacBook running Windows inside of Parallels. I've got the high retina display kicked in, and so I'm running the main Windows desktop with it's 250% scaling. On the right side, the lighter blue, because it's a gradient background, is showing the my external monitor, which is actually larger physically. It's a 27-inch monitor, but it just has the Apple 27-inch monitor that has 109 DPI, about 96, so it is running at 100% scaling. And as you can see, the Notepad instances on each of these displays looks noticeably different. Very similar, but there are some nuances, and we want to take a look at that. And one thing to note right off the bat is that if I drag the one high-res, high DPI version of Notepad over, you can see that it's quite large when it's on that. Now, once more than half of my window gets over onto the smaller desktop or the external desktop here, then you'll see that the windows are exactly the same. And so the Notepad app, part of Windows 10, does support high DPI. We're going to talk about the different ways in which it supports it in a little bit. But in this particular case, it certainly is nice that as I drag this over, it comes and shows this. Likewise, if I were to drag this instance over, it gets big. But one of the things that I like to point out is that as we move from one to the other, notice the spacing between the menu items. And even when we drop them down, this is what we're very much used to seeing running on our 100% scaling over on our traditional Windows desktops. When we go over to the High-DPI, the 250 percent scaling, if it was truly 250% that went across the board, then I would expect everything to be in the same relative position. So the length of my text, because it's a fixed font size text here, should end the same on both sides. So whether I'm running over, in my regular desk right under the view, well, it's certainly not doing that. It's much larger. And so you'll also see that because of the font scaling that happens, the menu items are actually much closer together, and they're even much closer together on the display. And so in certain cases, this is certainly adequate. This works fine, but it's not always ideal. We tend to get spacing problems when we try to make things high DPI. The one thing that is nice is that the text is so much crisper. When we look at this, this is using a large font, so that the text, the curves, the anti-aliasing, all of that is very crisp and smooth, which is ultimately what we're driving for. And the challenge is finding that good balance of, okay, do we get the good font sizes? Can we manage spacing? What about graphics and the images that we use? That is a big part of what happens, or one of the side effects, if you will, of going to high DPI that we have to come up with a solution for. Unfortunately, the most recent versions of Delphi do exactly that. And so we're going to dig into that a little bit later in the session. But let's talk a little bit more about why high DPI is so hard on Windows. Simply put, it's really historic. It goes all the way back to how Windows designed how to handle a device unit, if you will. They called it a dialogue unit. And it was a way to, old Win32 even goes back to just traditional Windows programming of how you would position something. And so there's a concept of a dialogue unit, which is 1/4 the average width of the system font. And it's supposed to be device independent, which it is, because, well, it doesn't matter. Whatever the system font happens to be, that's this size. But the problem is it doesn't map to a physical dimension. The system font can change. So my dialogue unit has no concept of a real world physical dimension. On top of it, it can vary. The vertical dialogue unit may actually be different than a horizontal dialogue unit. Now, that's great if you're familiar with dialogue units, but the problem is no one uses them anymore. Even .NET and WinForms and XAML, and obviously VCL is all pixel based. Microsoft itself has decided to go with pixels as defining the different aspects and dimensionality of our user interfaces. Well, that's problematic because pixels don't have a consistent physical size. They used to. That was where the whole 96 dots per inch came from. But now they don't. A pixel on a high resolution 4K monitor is a physically different size than it is on another display. And without some sort of way to map our pixel dimensions to a real live size, that gets very problematic. And one of the things you might be wondering, if you have any experience with Apple's products, Mac and iOS operating systems, they do everything based on points. And so 72 points per inch. In those environments, PPI stands for points per inch. And you can see that if you dig in deeper, all their monitor resolutions are all driven by that. And that's really historically, from that side of the view, from all the graphics publishing that Apple started out doing, really kind of became well known for. Now, obviously, it's a much wider range, but they've benefited with, when you design something for the old iPhone, which was, it had a standard, points per inch, 72, and then you jumped up to their Retina displays, they kept the same points per inch, and then they just applied the scale factor to that. So everything rendered appropriately. Well, it gets a little bit more challenging on Windows because you've got physical dimensions of the controls and the forms and so forth. You also have point sizes for the fonts, but even the fonts themselves may not be honoring the sizing and the scaling appropriately based on the measurements inside the font. And so you get all these little nuances. Hence the menus don't really look the same when I scale it up by 200, 250, or 300%. The fonts get bigger, and then the spacing gets smaller, or the spacing gets bigger because you're doing all these extra scalings. And without a physical dimensionality to scale against, you're going to have this gap. So with all of that complaining aside, we still want to support high DPI. How can we make our applications look much better? Because as we'll see when we look at the example, if we don't do anything, Windows will render them in a passable way, but it doesn't look that good. One of the whole reasons for getting a nice high resolution monitor is so I can cram more pixels in there. I can see things crisper and take advantage of that. If Windows itself can fix some of the scaling issues that happen with dimensionality, then really we can get really powerful displays. But in the meantime, there's a lot that we can do in order to better support high DPI displays, and specifically high DPI scaling, because really that's what it all comes down to. If you really wanted to use everything pixel based, you certainly could. Everything would be extremely tiny, and so it doesn't make sense to do that. But really what we're going to do is we're going to be, as VCL developers, we're going to be using our pixel as our unit of measure, and we're going to be able to determine what our pixels per inch are, and then kind of work with the scaling factor that's defined in Windows. So the next section really is to describe what are these scaling options that we have. And so Microsoft has evolved the way it supports high DPI with the last several versions. There was a little bit in Windows 7, not a bunch. There was more that was added into Windows 8, and then a lot more added into Windows 10. And so looking at it from kind of the current approach of today, and pretty much Windows 10 has been out there for a while, we indicate to Windows what kind of level of DPI scaling support we want to support or can support by adding an entry in the manifest. And we'll see how we do that in Delphi itself. It's in the project options. And there's a variety of settings that we'll go through each one, because it's important to understand what different combinations give us, what different effects that they give us, and ultimately there's really only one choice. There's two. There's one, you can don't do anything, or two, here's what we want to support. So looking at DPI awareness, the first one is unaware. Really, that means that our app is going to be rendered at 96 DPI, just like it normally was. It's going to assume it's running on a standard 100% scaled monitor. If you were to move the form onto a monitor, or you're running it on a monitor that has a higher DPI, Windows simply stretches the form. The app doesn't think it's any bigger. It just looks bigger on your monitor. And you have all the side effects you would normally expect for that. The text, everything gets scaled up so it becomes pixelated because you can see it. Images that you have, again, become pixelated because it's using a low res image on a high res, high DPI display. So it works. One of the things that's nice on the unaware side, to be totally frank, is that you don't get the positioning problems or the relative positioning problems and the sizing between control issues that you do when you start changing fonts and scaling and stretching stuff. Everything is in the same relative spot. It just doesn't look great. So not ideal. You can go with system aware. It's another manifest setting. You can set it inside of your project options. This is interesting. Again, this kind of goes way back, one of the early, how Windows has evolved it. This simply means that when you launch your application, regardless of which monitor it starts up on, it will get the DPI scaling value of the primary monitor the user logged into. And so, and I'll show examples of all of this as we go through. But as you can imagine, in my case where I've got a high-res, high-DPI laptop display, external monitor, when I show this over on my external monitor, it's not pretty. You will see that it stretches things. As it's noted there, is that if you move it to another display that has a different scaling factor, Windows just scales it. Well, in this case, it's actually the opposite scaling. It scales down because in my case, and we'll see the example of this, is it renders it really large because I have a high-res, high-DPI scaling. Then I go down, it stretches it the other way. Again, not really ideal either. In Windows 8, Microsoft introduced a functionality, DPI awareness, called per monitor. And this was to handle, okay, we know that systems have multiple monitors with different DPIs on it. So when I move my window, my app, from one monitor to another, the top level window gets notified of the change. Well, that's great superficially. Not everything is handled for that automatically, as we'll see, but more importantly, it doesn't even handle all of the things inside of Windows properly. And so, as the demonstration in just a minute will show, you can get some really odd behaviors when you bounce between one monitor and the other, even with this per monitor version. Now, Windows 10 Creators Update, Microsoft added two new kind of high DPI scaling supports. One's called GDI scaling, and I will make a note here is that this particular option is only available for VCL in 10.4. I mean, technically it's available in 10.3, which all the other scaling DPI awarenesses were added, but you have to do it externally with a custom manifest. In 10.4, GDI scaling is an actual entry that we can use. But what it does is it actually indicates to the GDI framework to say, hey, this application is really not designed for high DPI, but when you go and move this on from a 100% display to one that runs higher, like 250 or 300, whatever it is, 200%, render any of the text that GDI rendered before and use a different font. So if you're scaling the form gets scaled up to 200%, well, change your font size from 10 to be 20. And all this is done internally by the GDI framework. You don't have to change your app at all. And it has some very interesting effects. It will update all the fonts in your app and make them look really nice and clear. You do have potential issues because, again, doubling the font size in points should actually take up double the amount of space. But again, depending on the font and the styling and the metrics, that doesn't always happen. So depending on the font you use, you may actually see some nuance, some kerning issues. Text doesn't fit into the clip bounds, like it should. Things that don't get covered, as we'll show, images aren't supported because they get stretched. And so it's kind of like this combination of, let me fix up the fonts to make it nicer and easier to read, but the images and things we still have to work through. Unfortunately, the techniques that I'm going to show about how to fix the images don't apply to GDI scaling because your app actually doesn't change its internal size. It still thinks it's running at the non-scaled version. It's just all GDI magic. So interesting, might be a cool stopgap if you want, but really to get the most out of high DPI support in the VCL, you need to use per monitor V2. And this was also added by Microsoft in the Windows 10 Creators Update. Your top level windows get notified that there's a DPI change. There's a window message. You can hook into it as well if you needed to become aware of it. But what's nice is that they took it to the next level to where the non-client areas get automatically resized when the new DPI comes into play. You get the same effect, any theme drawn bitmap. So checkboxes and radio buttons and so forth, all of that gets sized up appropriately for the different DPI scaling. Operating system dialogues, your font, your open dialogues, they all look appropriate based on the new monitor's scaling resolution, scaling factor. So really, really nice to do. So for the next several minutes, we're going to take a detailed look at each of these different DPI awareness settings with the same application, and we'll see really how does it affect each one. And to start, we're going to look at the unaware value. So in our first custom example with a VCL application, we have this test High-DPI application. There's nothing real fancy about it. It has a variety of different controls on it: checkboxes, radio buttons, edits, combos, list boxes, of course, with a scroll bar. We've got toolbar. We have some images, which is one of the key pieces we want to take a look at. Glyphs coming from the Windows theme. So how do they update? How do they look? And so we're going to get a chance to see how all of this works. And one of the things that these buttons down here do is we'll dynamically create a control and then go ahead and remove it, so we can see how that behavior operates with the different DPI awarenesses that are available. This first one is the unaware. And so this is if we don't want to do anything special about our apps, we just want it to run and be able to run reasonably well, both in a 100% traditional 96 DPI type system, as well as a high DPI. And what we will see is as I drag this over to the larger, well, I should say the more dense, the higher DPI, 250% scaling, we can see that everything gets scaled out. So there's no difference. There's nothing being re-rendered. You definitely can see the pixelation around the images, even around the text, the curves of the C and so forth. All of the buttons actually, if you click them, will actually cause the dimensions of the form to show up. And as far as the form is concerned, even running on this high DPI monitor, it is still thinking it's 425 pixels by 405. Another thing that we'll bring this up later is the font dialog box comes up, also just like it would. It's all anti-aliased, and you can tell that it's not using the high DPI capabilities. So next up, we're going to look at what it means to be system aware. Next up, we'll take a look at the system aware. So this time we've set the DPI awareness to system aware, and what this means, if you remember from the slides, was that it detects the scaling factor and the size from the primary monitor that when the user was logged in, and we can see that in play here because I logged in on my high DPI display, and I've just pulled this over onto my standard display, and what we immediately see is that the images are extremely small. Even the sizing is kind of increased, but the fonts and so forth don't look all that great. The dimensions is much larger. That's because those dimensions are what the form looks like over here, and so the size gets scaled up to be 100 or 10,055 by 102 or 1002. The images are still the old 16 by 16 images. That's why they look so small. And so we get the nice fonts that look great on the primary monitor, but dragging it to a lower def monitor simply stretches it, meaning scales it down. And so it's not much better than scaling up. You don't get a great impact. So we're probably not going to be using systemware. Let's take a look at some more recent evolved functionality that Windows has added to High-DPI. So in this iteration, I've changed the DPI awareness to per monitor. So the original version back in Windows 8 that Microsoft added. And I started on the high DPI display this time around for a specific reason, because it looks like we're kind of in the right direction. We still have issues with the bitmap images being way too small, but the text is looking nice and crisp. Spacing seems to be pretty well. If I invoke the display, we see that we are using the larger form size. That's great. But one of the challenges that we have with version 1 of it is when we go and move this to the other display, we don't get quite the effect that we're looking for. And a lot of this has to do with in per monitor, the original version, it didn't take care of detecting DPI changes between forms. So certain things it did, like certain text elements, it would do that, but the glyphs, common controls, the scroll bar, system elements, and things like that would still retain their old sizing values. And so that's why we get this very large, spacing scroll bar. Even though the font was updated to display correctly, it wasn't. And there's even an artifact with respect to the spacers in the toolbar control that causes some challenges there. And so that's the other interesting thing about this, is that it's a little different when it starts up in the other monitor. It'll still start up big, but then some of the spacing between the toolbars goes away. But again, still not an option. Really don't consider per monitor a viable choice. So in this example, I'm using the GDI scaling. So if you remember, this was one of the two new DPI awareness settings that was introduced in Windows 10 Creators Update. And so this first one is GDI scaling, and it's really interesting, to be honest, because it's a way that we can essentially uplift our apps and making them look a little bit better, but not necessarily perfect. And but there's some trade-offs here. So let's take a look on the 100% display, our standard one. This just looks like it normally does. So nothing true dramatic there. Everything works as expected. We do see that the size of the form is 425, but it is multi-monitor aware. And so if I drag this over to my high resolution display, one of the things that we'll see is that all the text elements have been updated to use a larger font. What's really kind of nice is the spacing between everything remains the same most of the time. Even the spacing between the menus looks good. Now, one of the things that we'll note is that it still thinks everything is the same physical size. So there's no scaling applied. So you can see that the form dimension is still 425 by 405. That's why also, if you look closely at the graphics here, they are, they're stretched. So it's if it's system elements or if it's text that's rendered by the GDI, then it will automatically apply a higher font in order to display that. So if you're doing 200% from 100%, it will double the font size. Most of the time that works great, but as I noted in the note discussion before, how it is possible that you could have some clipping and some spacing might not be accurate. But as a quick uplift, GDI scaling is actually not bad if you're okay with the graphics. Obviously, when you're doing multicolored graphics and lots of curves, the pixelation does come in, and especially if you're going to say a 300 or even 400% scaling, then it can be much more noticeable. Fortunately, as we're going to talk about the final DPI awareness in the next example, and then how do we leverage fixing the images that are in our applications. The final DPI awareness setting that is available is per monitor version 2. And if you're using Delphi 10.3, that's available. It's also available in 10.4. GDI scaling that I showed in the previous example is only in 10.4. It wasn't included in the 10.3 release, but it is there now. It's very similar to the GDI scaling when it comes with respect to the fonts, but there's a whole lot more that it does that the GDI scaling doesn't take care of, and the system aware and the per monitor version 2 one does. Because remember, everything in the GDI scaling one, it was still kept the old size. So it just kind of did a little trick. And what was kind of neat is you could actually make a separate manifest on your application and have your app run with GDI scaling. So if you have an app that you want to have better font support, but it's not going to be updated, you can put that manifest on the application without recompiling. So I mentioned it merely as an alternate way that you can look at this. But per monitor 2 version 2 is really what we are looking to leverage. And so again, our app looks normal as we would expect, menus and so forth when we're on 100% scaling. Now if we go to and bring this over to our high DPI monitor, we do get the nicer fonts, so we know we're leveraging larger font sizes. We still have to address the images, and we're going to take care of that. One of the things that we can note, is if we have this scroll bar here and I move this back over, the scroll bar changes. The glyphs change based on which display I'm on. And so all of that's great. We can also see that the actual size of the form is being scaled. So from one to the other. And so if I bring this back over to the smaller size and update it, we'll see that yes, that's the smaller window. One of the things that we'd like to try out is we're going to also look at this a little bit later on at what it means to make a dynamic control. If we go ahead and remove this, bring it over on this side, update my display, it's larger. If I go ahead and add this, I've got a really tiny button because right now the way this app is written is to handle thinking. It doesn't take into consideration I'm running on a higher DPI or a scaled DPI system. And so we're going to look at addressing the remainder of this session on how do we fix these images, because that's really lacking right now. And then what do we need to do programmatically should we need to be aware of the scale settings that are being used by the system. So that's what's up next. So in order to handle the image issues that our application has, we need to look at two new components. The first one is called a T-image collection, and it is a shared repository of images with different resolutions. This is, if you've built an icon, you kind of have the same concept here. So you're 16 by 16, 24 by 24, 32 by 32, on up to as high as you want to support. What's interesting is because it's a shared repository, it's another non-visual control, you can put it anywhere. So you can put it on a data module that gets shared, you can have it on your main form, so forth. The key piece is that it holds different resolutions and they're associated with an image. So a given image index, or identifying an image, will have all of these other resolutions around. So by itself, it it needs another piece, which we'll get to, but one of the things to do that we'll want to keep in mind is when we load images into the image collection, and I'll take a look at this in the demo in just a minute, is, if you have the sizes built into the names, it can automatically figure that out and create the collection of images organized for you automatically. And so we'll see how the benefit of doing that. If you don't, it doesn't matter. You can add them in manually. It just takes a little bit longer. The corresponding component to your image collection is the T virtual image list, and it's designed to connect to an image collection and extract out of it a subset of images based on the current DPI for the current form. So based on the size of the image you originally used on your 100% scaling, if you move over to 200% scaling, the different resolution image gets extracted out from the virtual image list. And because the virtual image list is just like it's compatible with a regular image list, you can use it in any control that connects to an image list. Now, one of the things to note is that because the virtual image list detects the current DPI of the form that the form is placed on, or the monitor, that you cannot share this across forms. So you don't want to put your virtual image lists in a data module, for example, or just the main form, because you might have a secondary form that's on another monitor and the primary form is on the main monitor, and it will have a different DPI value. And so if that happens, the bitmaps won't necessarily render correctly, or the images from the image list. Another nice feature that I'll show is the autofill. So if you don't want to restrict, like your image collection could have 20 images in it, your virtual image list for a given form could just use 5 of those, and you could manually pick in the 5 you wanted from the collection. Or you can turn on autofill, and it will bring in automatically all of the images from the collection at the appropriate size to support the DPI scaling that is currently in place on that monitor. So let's switch over to Delphi and take a look at just what and how we use these two new components. Okay, we're back in Delphi. We have the same application we were showing, the different scaling, the DPI awareness settings. But now let's take a little deeper look into how these images are supported. So the application uses an action list and main menu. The action list connects to the image list 1, which is down here, and is set up as a 16 by 16 set of images. If we double click that, we can see their basic images, and of course, the pixelation shows up when these get scaled to be bigger, but we're going to go ahead and cancel that. Same thing, our toolbar also references the same set of images. So if we look down to the images property, we'll see that it's image list 1. Well, to fix this, to leverage the high DPI capabilities, we want to use the image collection. So I'm going to get one of these, and I just know I'm also going to need a virtual image list. So I'm going to drop that down, and we'll position these so I can get to them a little bit easier. And so the image collection is right here, and if we double click on this, we can go ahead and bring up the editor. And the way it works is you can go in and you can add a file, and this is where if we have the size file or sizes in the file name and we have a separator, it can actually do things a lot easier for us. So I'm going to go and scroll up to my conference directory here, into my demo files, and I've already set these up. Go into edit. I'm going to pick all my edits, and you can see how this is, edit copy with 16, 24, 32, 48, and 64. And so by opening all of those, it tells me what images I have, and then for each one of those it breaks them down into the different images that make up it. And I like to create a category if you do. That way, if you're interested in an image, you can quickly get to it and isolate it. And then I can go in and add more. I can go back in and add all the file ones. Come over to here, and I'll set the the category here. This I wish was a little bit better, that you could do this ahead of time, give me the category and put them in, but it's not quite ideal that way. But so I'll add my file category, and so I've got everything set here, and that's my collection. So I've got a number of images. Here's all of them, and then I can go ahead and connect them or use them in my virtual image list. So first thing I want to do is I close that dialog and go over to the virtual image list, and first thing you always want to do is connect it to the image collection you're interested in. So you could actually have multiple image collections. You might want to do that if you have different categories. In my case, I wouldn't necessarily do that in the file and the edit, because I'm going to probably want to use them from the same image list, meaning the edits and the file operations are all in my toolbars together, and that's just one image list. So a virtual image list can point to one image collection. Usually you'll have one. Now the virtual image list, you can go and double click on that, and you can go after, now that I've connected it to an image collection, you can go and pick which images you want from the collection to be in that virtual image list, which is okay. It definitely works. And an alternative is, if you want all of them, you can just turn on the autofill, and it will, we can already see that it's brought in the 11 images from the image collection into my virtual image list. And so now, since virtual image list is identical to an image list as far as consuming, I can go to each of these controls and change this down to virtual image list. I'll go over to here and change this to virtual image list, and then finally I can go down to my menu and change that to virtual image list, and that's it. I've made all the setting changes. This is on my form that is going to detect when the DPI changes as I drag it from monitor to monitor. And when we go and run this, we're going to see just how this looks on our high resolution, high DPI displays. And so we'll go ahead and run this now. So after making the changes, incorporating the image collection and the virtual image list, I'm now running my same application with per monitor version 2 awareness, and with these high-res images available in the image collection. And so when I'm running on the 100% scaled system, everything looks just like it normally would. However, what's really nice is when I bring this over to my high definition display, we see the font changes just like we saw before, the size, but notice the images. They are using the high resolution images because the scaling factor supports it, allows it. So the virtual image list detects the DPI setting from the system on this monitor that the form was moved to, and then goes and refreshes its list of images from the collection to extract out the appropriate sized rastered image, so that we get these nice crisp high-res images for the display. And again, it still has the larger size, but notice how our app is now getting real close to doing a much better job of supporting high DPI systems. And so the one piece that's remaining is, how do we handle the dynamically creating of the controls, and that's what we're going to be looking at next. So to handle the last bit of our dynamic control creation, we have to look at some API functions that are available in the component framework to help us with that. And it all goes down to the Windows API function, get system metrics for DPI. The problem with that is that's only available on recent versions of Windows 10, and so you'd have to check for it and all of that. Well, Embarcadero made that all that easier by adding a new function inside of the VCL controls unit called get system metrics for Windows. And so that's nice that it's available, for us, that will do the checking of the right availability and call the right function. However, they actually took it a step further and made it even easier from our controls, because that's usually where we're calling this function, to check the width of a scroll bar and things like that. Is that we can, there's a new get system metrics at the T control level, which is the ancestor for all of our stuff that's visual. So the forms down to the buttons and all of that. And so it now calls get system metrics for window, which is really nice. And so so if you need that, if you have code in your components that is calling get system metrics, you'll definitely want to look to see if it operates the same way with the new version, where it's using this get system metrics for window. You may already be taking advantage or handling DPI changes. In that case, you can simply change the path, the unit scoping for the get system metrics to be the WinAPI.Windows. Get system metrics, and it will call the old API function. So that's up to you. But what really, for most of the time you'll run into or need to get access to, is the current points per inch. Now, why it's not called DPI, that's just what they decided. It's the current, and I said points per inch, it's actually pixels per inch. And so getting that, the PPI or the DPI, this makes it really easy. So there's a property that's available for us to use, and that's what we can leverage in order to determine the scale factor that's being applied on the monitor our form is on, and then we can update things appropriately. So let's take a look at how we can update our application with the dynamic buttons. And so let's take a look at over into Delphi here. And right now, if we go and look at the add button and look at the implementation of that, you can see that it's pretty straightforward. We're dynamically creating a button, we're setting the different values, apply the bounds, and we're good to go. But again, if we're running on a high DPI scaled system, this isn't going to work right. So we need to adjust these dimensions based on the current scale factor. And to save us me typing all of that in, I've already kind of set that up for us, and then I'll adjust it and I'll explain what this stuff does. And this is just a little helper to see how that runs. So what we're doing is we're using the multiply divide function to apply our scale factor. And the scale factor is really the current PPI of our form, and using the base value of 96, since that's what everything is driven on. So if the current PPI is 96, this is a multiply divide by 1, nothing changes. But if I'm scaling this up and my current DPI is much larger, we do the division, we're going to get different values, and then we'll adjust those values appropriately. And so as we'll see, that's all we really needed to do. Let's go ahead and run this, and we'll see what it looks like over the two monitors. So after we've made the modifications for our detecting the current PPI and updating the dynamic creation of our control, let's take a look, see what happens. So just as before, we have our original size of our forms. We have, go ahead and do the control creation. We see that we're running at 96 DPI. Go ahead and clear that. We'll drag this over to the larger monitor. We can see that we have the larger size. Let's go ahead and dynamically create it. We can see our DPI has changed to 240, and now by using the current PPI property value, we can now adjust the size of our dynamic control to account for that creation size. And what's really nice is by creating it that way, when we bring it down over to the smaller size, it detects it, even though the change is set, we can clear that out. But this really gives us the support for high DPI that we want in our Delphi VCL applications. And we've now come to the end of my session. I hope you got a better insight into the various ways in which Windows supports high DPI and the ways in which Delphi and the VCL provide support to those capabilities through the DPI awareness settings, the new image collection and virtual image list, and then the new functions, the APIs in the RTL, and the new component T-control properties that we can leverage in our applications to better support high DPI, varying scaled applications. For now, thank you all for joining and attending. Please stay tuned for any questions and answers. And the sample application that I showed will be available on the my Delphi by Design blog area in the download section, so you can take a look at that and try those out for yourself. And once again, thank you very much for attending, and enjoy the rest of DelphiCon 2020.